Basically, I didn't understand like the other one, so like kind of like the reflection of it. So that
Oh,
isn't as bold. So I understood how to plot it and everything. I just didn't understand the why
whatever.
we did the second one.
Oh, so the reflection is actually quite interesting. So, like the reflections, you reflected it over both the x and the y-axis.
Kinda. So if you look at the picture,
Mhm.
if you look at the picture, it's not necessarily reflected, but it's kind of like it just opened up more.
Oh, so you're not. So those aren't reflections at that point. Those are what you're calling more of your stretches.
Uh-huh.
Mhm.
I didn't understand like how we got to that.
Oh, okay.
Mhm.
So were you graphing something like the absolute value of x?
The absolute, yeah. So it was fx equals 4 and the absolute value of x.
Okay, so the 4 times the absolute value of x.
Yeah, but they didn't put the times.
Right, they just put 4 absolute value of x because the times symbol is always assumed, right?
And then it says plot 3 points. So the absolute value of x, of course.
Hmm.
So, and then you multiply it 4 times x, correct?
Yeah, so what I'm going to do is I'm going to use decimals. You've used it before, correct?
Yeah, we use it in class.
Okay, so the reason I'm going to do this is not right. Okay, so yeah, if you do f of x is equal to the absolute value of x, you get that, correct?
Yeah.
But if you get the 4 times the absolute value of x, you'll notice that it's a lot steeper.
So is it just because it's plotted on the 4?
So the 4 does something to the absolute value of x.
Mm-hmm.
So 4, well, we know it's multiplying everything by what?
4.
Right. So if you multiply everything by 4, the result of any number is going to be multiplied by
4.
what? Yeah, 4.
Mm-hmm.
So what you're going to see on the graph is that if the value here was 2, the value here is now 8 for f of x.
Mm-hmm.
And you can pick any value, and that would be the new value would be 4 times as large.
Yeah.
What also happens is you can think of this as stretching it out vertically 4 times its length.
Mm-hmm.
So what they're trying to get at here is that if I was, well, if I had written this a little bit differently, if I put this as g of x, you can see like if I put 4 times f of x, what you'll see is a green function that just overlaps the blue one.
Mm-hmm.
So if you stretch out f of x 4 times in the y direction, you're just going to get 4 times the absolute value of x.
And how do you do that? So like if I were to multiply 4 times x or the absolute value of x.
Right, so if we started off with this f of x equals the absolute value of x, let's say we wanted to get 4 times the absolute value of x,
Mm-hmm.
right? Well, we know the absolute value of x is the same thing as f of x, right?
Yeah.
So we can substitute this in for this to get 4 times f of x.
Mm-hmm.
And because the 4 is multiplying the entire function, you're stretching the entire function that you start with by a factor of 4.
Oh, okay. So plotting it, because I think what we plotted first was the solid. So in your case, the blue one, we
Okay,
plotted that one first, and then I think we plotted the red one second.
okay. Usually it's easier to plot this one first, the red one first,
Mm-hmm.
and then obtain the the result 4 times the absolute value of x second based off of that.
Uh-huh.
Because if you do that, then you kind of see where you're just stretching the function by 4, by a factor of 4.